Hello everybody, welcome. I'm going to be running through an overview of the upper limb today. This is the first video I've been making, so please do give me feedback at the end. I think we'll be mainly going over the bone structure. I might mention some muscles. I very doubt we'll do neurovasculature, but let's have a go. So to begin with, I'm just going to get the relevant bones of essentially the body for us to look at. And I'm going to give you a framework of which to understand the bones of the body, which is commonly used. So there's two sort of systems of bones. They are called the axial skeleton and the appendicular skeleton. The axial skeleton contains the skull bones, the neck bones, the ribs, the sternum is over here, the vertebrae, and the sacrum, which you can see over here. The other system of bones is called the appendicular skeleton. Now there's the superior appendicular skeleton and the inferior appendicular skeleton. Today we'll be focusing primarily on the superior appendicular skeleton, which consists of the pectoral girdle with the scapula and the clavicle, as well as the bones of the free part of the upper limb. Now to focus more on that pectoral girdle, I'm going to get up a picture of the clavicle and the scapula. It's important to note that the appendicular skeleton articulates with the axial skeleton, at least in the upper part of the body with the upper limb, at the sternoclavicular joint, which is where the clavicle articulates with the manubrium over here. And this joint here is called the sterno for sternum, clavicular for clavicle, sternoclavicular joint. Now to move more specifically to a discussion of the clavicle, we can see here, I'm going to give you an anterior view of the clavicle. The clavicle is involved in connecting the upper limb to the trunk of the body. As you can see here, it's medial 2/3 convex anteriorly, its lateral third concaves anteriorly. And the site of transition between concave and convex is a point of susceptibility. So the medial 2/3 convex anteriorly, lateral 2/3 concave anteriorly. Yeah, I think I said that right. Medial 2/3 convex anteriorly, lateral third concave anteriorly. The site of transition marks a potential point of susceptibility, which may be involved in fractures. To briefly discuss the articulations of the clavicle, we've discussed the sternal end over here, which is going to attach to the manubrium of the sternum at the sternoclavicular joint. On the other end over here, we have our acromial end. Now this part of the scapula is called the acromium. It's the lateral extension of the spine of the scapula, which we'll be discussing briefly. And this over here, because this is the acromium and this is a clavicle, it creates the acromioclavicular joint. The clavicle is a frequently fractured structure, particularly in children, and often occurs in a fall on an outstretched hand, in which the shock will be transmitted to the clavicle and it will break. The clavicle and scapula of the pectoral girdle are supported, stabilized, and moved by axio-appendicular muscles, which are just muscles in this region. And because particularly the scapula has 17 muscles attached to it, it's quite sturdy. It's unlikely to break or get damaged. So then to move to our scapular structure, we've talked about the 17 muscles and that fractures are uncommon. If we look at it posteriorly, if we look at it posteriorly, we can see some structures that we will discuss. We can see the spine of the scapula over here. This spine is going to separate the supraspinous fossa from the infraspinous fossa. And as quite helpful with the name, the supraspinatus muscle attaches to the supraspinatus fossa. Infraspinatus muscle attaches to the infraspinatus muscle. For some landmark anatomy, this scapula overlies the 2nd to 7th rib. Some sources will say 3rd to 7th rib. It's also important to note that the supraspinatus, while it originates here, it's going to have a distal attachment in the greater tubercle, which we'll discuss as we do the humerus, which I'll talk about momentarily. Might talk about that now, actually. So no, we'll do it later. We'll do it in order. You can see here how the spine of the scapula is going to continue laterally till the acromium, which is a subcutaneous point of the shoulder. So this point can be palpated and often is done during examinations. The root of the scapular spine on the medial end is at a T3 level, whereas the inferior angle of the scapula is at a T7 vertebrae level or the 7th rib. It's easily palpated and often visible, and is frequently checked in an examination. Right. I'm now going to show you the glenoid cavity, which is over here. The glenoid cavity articulates with the head of the humerus at the glenohumeral joint. It is shallow, concave, and an oval fossa. It's an important structure that is involved in the articulation of the humeral head with the scapula. Because this is quite small, this joint is quite unstable, but because of its instability, it has quite a lot of mobility, which is kind of defining of the upper limb joint, the shoulder joint. And this joint itself is a multi-axial, which means you can go in many directions, synovial ball and socket joint. This is a socket, the humeral head is the ball, and that's how you can think of it. There's something called a glenoid labrum, which is this fibrous thin. We'll talk about it actually maybe later, but the glenoid labrum is a little bit of fibrous connective tissue that is involved in deepening the glenoid cavity to increase stability. We'll discuss that when we do the ligaments. Finally, in our discussion, we should talk about the coracoid process, which is here. It supports, it's superior to the glenoid cavity and is involved in supporting ligament attachment, particularly the Coraco clavicular ligament. You can see the Coraco clavicular ligament has the trapezoid ligament and the conoid ligament, which I remember being asked about in a PACA once. Okay. And as I said before, the glenoid labrum deepens the joint space to increase stability. So that was a very quick run through of the bony structures of the clavicle and the scapula.